Hi students, good evening all. Hope all of you are doing fine and welcome to the one more new session of JEE Advanced. Right. So as you know, the previous session we were doing on the ray optics. Okay, in that we have discussed some numericals on that. Okay, today we are going to see one more new session which is in the wave optics. Right. So we are going to see different methods how to solve in the problems of the wave optics. Right. And mostly in this wave optics, we are going to find out in the Young's double slit experiment what are the different conditions what we are going to see in the Young's double slit experiment and different modifications what you will do for the in the Young's double slit experiment. Okay, so we have been getting a lot of numericals both in the JEE mains as well as advanced. Okay, right now all your preparation is going well for the JEE advanced. Okay, and I'm sure that this session is going to help you in this particular chapter. Okay, so how to make out the problem solving skills and all. Okay, so anyway, so let us start today's session. Right. Right. So just to some few points we'd like to add before exactly starting the numericals for today. Let us see one by one. Right. Okay. So here, whenever in the Young's double slit experiment, and you are having, there are two slits. Okay. So mostly the source is placed here symmetrically with respect to the slits. But suppose if the source is placed exactly here, in front, exactly in front of one of the slits. Okay. So this is D and this is your capital D. Okay. Immediately, how we are going to take this path difference between these two. So one wave is coming like this, the other one is coming over like this. Okay. Right. So here, how we are going to find the path difference first of all. So this is your D by 2. Right. This is S1 and this is S2. So here to here minus here to here, this will travel fast, this will travel slow. This takes more time to reach here, this will take less time to reach here. So definitely it will create some geometrical path difference. So which is equal to SS2 minus SS1, right? Okay, so here you will be finding out SS2 minus SS1. So what exactly that you can take? Okay, so SS2, can I write this as under root of, so this value, can I write this as under root of D square plus capital D square, okay, minus SS1 is nothing but capital D, right? Now you take capital D common here, okay, so 1 plus D square by capital D square whole power 1 by 2, right? So if you take D square common, 1 plus D square by capital D square whole power 1 by 2. And then if you apply the binomial approximation also, so capital D into 1 plus 1 by, okay, so D square by, right, 2 capital D square, binomial approximation, minus capital D. So that will give out to be like D square by 2 capital D. This will be the geometrical path difference between SS2 minus SS1, D square by 2 capital D, okay. So whatever this length is there and whatever this is there, so D square by 2 capital D. So most of the time whenever such situations are arising, we are going to take directly D square by 2 capital D as the geometrical path difference between this and this, okay, SS2 minus SS1, okay, hope that is clear. And one more thing also very much useful in the wave optics is the optical path, okay. Whenever the geometrical path of x is equivalent to in the, okay, so whenever suppose in a medium, for example, in a medium which is having nu and this is a x, okay, this much distance, if the really the wave is traveling this much x distance in a medium whose refractive index is nu, right? So it is traveling that much distance, then how much distance that it is going to travel in air? So definitely, because here it is traveling with a lesser speed, so in air it will travel with more speed, so that is why it will going to travel nu times of x in the air. Okay, that means in a medium, a distance of x in a medium of refractive index nu is equivalent to nu times of x in air. Hope this is also, most of you know this. Okay, so we are trying to use this property also, okay, and also this one in the coming numericals, right? Okay, so we'll start the numericals one by one. So starting with the first one, a source S is kept directly behind the slit S1, right? S is kept directly behind the slit S1 in a double slit experiment. What will be the phase difference at point P? Exactly, you are talking about point P. What is the phase difference? If a liquid of refractive index nu is filled, okay, between the screen and the slits. So here you are filling the liquid of refractive index nu, and source is also not symmetrically placed. Okay, so in that case, what will be the phase difference at point P? They are asking. Here they are selecting on point P, and here how do you take the phase difference? Okay, when this is filled with some liquid of refractive index nu. Okay, hope the question is clear. And in that second bit, same liquid is not filled between the slits and the screen, rather it is filled between the slits and the source. So between these two. So two cases, right? Okay, so we'll solve one by one. So I'll just redraw this one, and also clearly given that L is far greater than small d. Of course, here it's actually L is far greater than small d. So the picture can be assumed like this. So here this is source, this is a length L, right? And you're selecting one point P, which is exactly d by 2 there. So that means in front of this one only, this is a point P, this is d by 2, right? And this is also d by 2 only, here also. Okay, now if we select, so one wave is going like this, the other one is going like this, right? And here it's going straight like this, it is going like this. Okay, if you take without any medium, then clearly how to take the path difference. First of all, here if you take S1, S2, yeah, this is already longer than this, right or not? And here also it is longer than this. So net path difference, what that you are going to write is, so the net path difference, suppose there is no medium which is filled, completely it is in air, right? So what will be the net path difference at point P between this wave and this wave, right? So that you can write it as, first of all, here this is already longer than this, okay, by an amount. Already I told you, whenever you keep exactly in front of this, so you can take d square by 2 capital D, check this, d by 2, exactly, what is the path difference? D square by 2 capital D, correct or not? So same thing, yeah, this is longer than this by an amount, d square by 2 capital D, and here normal one, YDSC, how you approach, right? What is the path difference between S2P and S1P, which is nothing but d sin theta you will apply, right? D is this distance, and of course this is longer, and here also this is only longer, so that is why net path difference will be plus. That you have to be very careful. Suppose if the same point P, instead of here, if it is here, then it will be coming like this. So here this is longer, but here S1 is longer. From S1, P will be longer. So that time you will be taking here in between minus. Okay, all right, right. So plus d sin theta is the path difference when completely it is in air. Now, but they are giving two conditions. You are actually filling with a liquid of refractive index nu, filled between the screen and the slits. Whenever you are filling between this position in this, okay, place, whenever you are filling with a liquid, whatever the path difference you are getting, okay, geometrical path difference which was in air, that will come as nu times of that. Okay, so here now you will be getting nicely the first case. You just add what? Nu. This will become the geometrical total path difference between SS2P and SS1P, because this is a medium of nu. Right? Now they are asking, this is the path difference, and once you get the path difference, you know how to find the phase difference. Okay, rest is very simple. So path difference net is equal to d square by 2d plus nu d into sin theta. Sin theta is approximate to tan theta. Tan theta is equal to y by capital D. Correct? So y is d by 2 by capital D. So you can write d by 2 by capital D. Okay, so that means d square by 2 capital D plus nu into d square by 2 capital D. This is the path difference. Right? Net path difference between SS1P and SS2P. So once this is the net path difference what you are going to have, then automatically you can find what is the phase difference also. Okay, so phase difference is simply equal to 2 pi by lambda times delta x. Okay, so that you can put it. So just they are asking the conditions, right? This is the first bit. Okay, next, if suppose in the second bit they are asking same thing, like between now the whatever the medium is there, that is filled between source and the slits. Here if you fill, what happens? That time also we'll try to write the conditions, and in this case find the minimum distance between the points on the screen where the intensity is half the maximum intensity on the screen. Okay, so that also second bit. Just see this question, right? So we'll solve the second bit also. First bit is simple, right? So you are filling this nu, so you are adding nu here, and this is the total path difference. And once you got the path difference, you will get the phase difference. Sin theta approximate tan theta is equal to y by capital D, d by 2 by capital D. Okay. Here 2 into sin theta d by 2 capital D. Right? Fine. Okay. So second bit, second one. So this also will try. Again I'll write. Now I'm keeping the source over here, right? This distance assumed as L. And you are selecting same point P. Now this is coming like this. Now this is the medium filled with the refractive index of nu, right? So this is already d by 2. How we are writing the condition now? First SS2 is longer than SS1. Okay, by an amount already you know, d square by 2d. This was in, now this is longer than this in the medium of nu. Now the same thing if you take it out in air, so you have to multiply with the nu times, because everything we are converting into the way, whether it is a path or path difference, we are trying to convert it into air, right? So this is actually the path difference what they will get in the medium, but when you take air, they'll get a more path difference, so you are multiplying with nu. And then this is also longer than this, so here you can nicely write d sin theta, d into sin theta. Sin theta is approximate tan theta is equal to d by 2 capital D. Okay, here it is air only. So this is your path difference, second time, for the second bit. And same thing, once you get the path difference, you can find the phase difference. So 2 pi by lambda times delta x, that's all. The second thing. And in the second question, one more bit is also asked. Let us see that. Okay, hope this is clear. So in the first time you are adding mu here, second time you are adding mu here. First time this was filled with a liquid, second time this is filled with a liquid. Okay, right. And also in the second bit, they have also asking something else. In this case, the minimum distance between the points on the screen where the intensity is half the intensity on the screen. So what should be the minimum distance between the 2 points on the screen where the intensity is half the maximum intensity on the screen? We know that when the two, suppose assuming that two slits, whatever the waves that are coming, they are having an intensity I naught and I naught. So maximum intensity is 4 I naught and half of that will be 2 I naught. Correct. So whenever 2 I naught is there, what should be the phase difference? Right or not? So when the simple thing here, suppose we talk with respect to amplitudes, because when it is coming to amplitudes directly you can use these phasor methods. Okay, so A and A, right? So if A and A, this is having A corresponding, for A intensity is I naught, corresponding to this A intensity is I naught, right? If both of them are in the same phase, A and A, both of them are in the same direction, you will get resultant as 2A. So correspondingly, because intensity directly proportional to A square, right or not? So this is for constructive interference, amplitude becomes 2A. So automatically 2A whole square, so you will get, because amplitude is getting doubled, so intensity becomes 4 times. So that is why intensity becomes this one, right? So this is for, you know, constructive interference where the phase difference is nothing but 0, 2 pi, 4 pi and all, right? Now, suppose what happens is, if these two are at 90 degrees, will you not get resultant as root 2A? When the resultant is root 2A, automatically, since intensity is directly proportional to A square, resultant is root 2 times A, intensity becomes automatically square of that. So root 2 whole square means 2 times. So that time, if root 2A means, you will get 2 I naught, right or not? So this is generally for 0, 2 pi, 4 pi and all, right? And this is for, come on, so 90 degrees. 90 degrees only A and A vectors method, A and A 90 degrees root 2A, right? Similarly, if it is 60 degrees, A and A angle 60 degrees, you know, in vectors, two vectors having equal magnitude A and A angle 60 degrees, will you not get root 3A? That time your intensity will become 3 I naught. Okay, please try to get the point. Okay, so these are all the ready-made things which you can know, so that it will be easy for us to solve the problems. Okay, and then comes out, so what else? 120 also we can try. 120 A and A with 120. So come on. So this phase difference is 120. A and A, resultant will be getting A only, because two vectors which are having magnitudes A and A, angle is 120. Angle is 120. You will get the resultant as A. So intensity, when resultant is A, intensity will become I naught. Okay, hope this table is clear to all. And the last one is of course pi and all. So amplitude becomes 0, intensity also becomes 0. That is a destructive interference. So this is a constructive. Apart from constructive, there are other things. So 90 degrees, 60 degrees and 120 degrees, where you will get intensities I naught, 2 I naught and 3 I naught, like this. Okay, hope this is clear. Now they are asking in this question, where the intensity is half of the maximum. Maximum was 4 I naught, half of means 2 I naught. Means phase difference is what? 90 degrees. That's all. So once the phase difference is 90 degrees, already you know how to find the phase difference. That you equate to 90 degrees, right or not? So if you equate this value to 90 degrees, phase difference, or when phase difference is 90 means what? Path difference is what? Here let me write the path differences also. Path difference also let me write. Okay, so path difference will be, here you will get 0, 2 pi means lambda, 4 pi means 2 lambda and so on. And here 90 degrees, see, for 2 pi it is lambda, right? So for 90 automatically lambda by 4, okay? And for 60 it is lambda by 6, because 2 pi by 6, 360 by 6, okay? And this is lambda by 3, here. So like these are the path differences, these are phase differences, this will be the amplitudes, resultant amplitudes, and this will be the resultant intensities. Okay, just have a check. So because all these things very much useful when we are solving problems, okay, like one involving lot of sub concepts involving, so these ready-made things, if you put out these techniques, that we can make it. Okay. Right. So here, so directly either you do phase difference and equate the phase difference to 90 degrees, or else equate the path difference only to lambda by 4. So this is a path difference which is equal to lambda by 4 you take, right? Okay, so they are asking that time you need not have to put for P, you have to select some other point. Okay, in the second case, just instead of P, at P you are getting this value and accordingly you will get the answer. But in this case, find the minimum distance between the points on the screen where the intensity is half the maximum intensity. So not this point P, maybe some other points where you will be getting the intensity is half of the maximum intensity. So you have to make some other points. So that point you take some other point here which is at a distance of y, right or not? You have to get the value for y. So that time what you are doing, so if whenever you are finding this d sine theta, so in place of sine theta, you are not putting d by 2. So rather simply you put, here I am showing you that part delta x is equal to, okay, first one is same, nu d square by 2 capital D plus d sine theta is approximate tan theta, some point y by capital D. This is a path difference, like this you have to take. So some point P here which is at a distance of y. And that path difference should be equal to, because you want exactly 2 I naught, that path difference has to be equal to lambda by 4. Now get the value for y. You will get the value for y. One value you will get. Second time again you want to get the value, means you equal to same thing like lambda by 4. Okay. After that you have to put it again 3 lambda by 4 and so on like that. And you will get the different values of y's. In that first point where you are getting the intensity as 2 I naught, that you locate this one, and next point again where you are getting the intensity again 2 I naught, again that point also you have to take. So between those two, what is the distance they are asking us? Okay, hope this is clear to all the students, right? Okay, all right. So now we'll move on to the next question. Just check this question. Two slits S1 and S2. Two slits S1 and S2 on the x-axis and symmetric with respect to y-axis. So this is the y-axis that we have taken, this is the x-axis. So these are symmetric, of course, with respect to y-axis, equidistant, or illuminated by parallel monochromatic light beam of wavelength lambda. So this is illuminated with a monochromatic light of wavelength lambda. Okay. So just instead of giving YDSC like this, they have given like this. That's the only change. Okay. Right. Distance between the slits is small d. So this is anyway small d, as we know. And d is very much greater than lambda. Yes. Point M is a midpoint. This M is a midpoint of the line S1 and S2. M is a midpoint. And this point is considered as the origin. Okay. So this you consider it as origin. The slits are in horizontal plane. Yes, these two slits are in the horizontal plane. The interference pattern is observed on a horizontal plate acting as a screen. Yes, so this is a horizontal plate which is acting on a acting as a screen. This horizontal plate is acting like a screen, but it is not fixed. It is connected to some spring, and definitely because of this M, it will oscillate also. Okay, right. Which is attached to one end of a vertical spring of spring constant K, the other end of the spring is fixed to the ground. So it's very simple. So I think they will be asking, like, when this is oscillating, this distance will change. Something like capital D is changing. Capital D is changing means automatically position of the maximas, because we know that the position of the maximas, this is a source. Suppose here if you have a maxima, nth maxima, this position yn, right? You know that position of the nth maxima is n lambda capital D by small d, which is definitely depend on this capital D, right? But this capital D only changing because it is oscillating. What was oscillating in the, vertical plane, now you can make it in a horizontal plane, right? Okay. Which is attached to one end of a vertical spring. Rest is all just like a springs and with mass m. T is equal to 0. The plate is at a distance of capital D far greater than small d below the planes. Okay. That this is exactly at capital D initially. But when you attach and spring is in its natural length. So m mass is there, spring is in the natural length. If you release this m mass from here, it won't stay there. Definitely it is going to oscillate with some mean position. So we know in springs, suppose whenever you keep a block and this is in the natural length and suddenly you are attaching one block, so it will oscillate with some mean position like this. This will become the mean position and initially you are releasing from rest, so this will automatically become the amplitude, and at the mean position your mg is balanced by kx, where x is the amplitude only, correct or not? So actually it will oscillate like this. So whenever you are releasing this from rest from the natural length, this will become the mean position, it will come up to here and till down, and then it will oscillate like this. One extreme position will be the natural length and the other extreme position will be the compressed length. Mean position also it is already will be compressed. So how do you find the mean position? So mg is balanced by kx. So mg is equal to k into x means amplitude only. So your amplitude you will get mg by k. This is separate. Okay. Right. So like that here also plate is oscillating. Now they are asking find the x and y coordinates of the nth maxima on the plate as a function of time. Right. Nth maxima. So nth maxima, what is the x coordinate and y coordinate? Here x coordinate means what we are showing here, yn, and this is y coordinate for them, right? Okay. So just the figure what we were taking like this, you are inverted like this and it is oscillating, right? Okay. Now, the thing is, suppose here you are having nth maxima from this center, okay, what you are locating. So this is, you can call nth maxima means xn, because the nth maxima you are taking in this direction. So xn is equal to, according to the formula, n lambda capital D by small d, but capital D keep on varying, so n lambda some d prime by small d. Same formula, n lambda capital D by small d, position of the nth maxima from the central maxima. Central maxima will be here only. And here you will get first maxima, second maxima, third maxima, and all this side also, this side also. You are talking about nth maxima. N lambda d dash by d. So where this is d dash because it is keep on changing with respect to time. This value of the distance between the screen and the slits, plane of the slits and the screen is changing with respect to time, right? So that we have to find. So for that, what we can do? So d prime. See, first of all, in SHM, in the SHM, whenever particle is released from the extreme position, generally we will use for a x equal to a cos omega t, right or not? So when it is released from extreme position, but actually you have to take the distance from here, right? So it's already d is there plus something, and whenever you take the equation x equal to a cos omega t, so just a little bit of SHM things I'll like to add. Okay, see here, suppose this is a mean position, this is the extreme position, if it is oscillating like this, right? So generally our equation is, if y is equal to, because it's oscillating in this plane, so let us use y is equal to a sin omega t means it is at the mean position and going towards right. But if it is here, then you have to use y is equal to a cos of omega t, where y is nothing but the displacement of the particle from the mean position, right? This is y from the mean position. But if you want to write from the extreme position, this extreme position, let us say particle is here, this is y, From here I want to measure the distance. So here to here what you will write? So definitely, because this is extreme position, this will be A. Okay, so here to here what will be the distance of this mass from the extreme position? This is the extreme position. So what is the distance of the mass from the extreme position? Means A minus Y, right? So you will write from the extreme position, if I want to write A minus Y, I will write some A dash, okay, or sorry, Y dash I will put better. So this Y dash is equal to A minus Y is nothing but A cos omega t. Why I want to write from the extreme position? Because finally I have to take the D dash. Okay, finally I have to take this D dash from here, no? That is the main thing. That is why I have to get the distance of this plate from this point. First I will take from extreme position, because already plus capital D, if I add, problem is solved, right or not? Come on. So simple, Y dash is equal to A into 1 minus cos of omega t. Now, this is the slits. I'll show it here. This was the initial position of the plate. Plate, I'll take it like a block. Okay, just imagine this is a screen, right? Better. So this is already capital D. This is a mean position of this, and it was, assume that this is only screen. It is oscillating, right? That's it. Already I was taking from extreme position to this, when it is somewhere here, this I'll take Y, no, but this I am taking as Y dash. The equation for Y means Y is measured from the mean position, then that time you will write nicely like this. But if same distance you are measuring from extreme position, you will write Y dash, which is equal to A minus Y. That's what I have written, right? So Y dash is already, you know, Y dash is what? A into 1 minus cos of t. Now, from here, what is the distance of the screen from here? D plus Y dash. So that is why your D dash is equal to D plus Y dash. So your D dash is equal to D plus Y dash is already A into 1 minus cos of omega t. You got what is D dash? That's all. Right. So once you are getting the D dash, right? So that is itself is the Y coordinate of the maxima, because Y coordinate of the maxima is nothing but the distance of the screen from the origin. Correct or not? Y coordinate itself is this one only. Y coordinate of the maxima will be somewhere here, let us say. Maxima will be somewhere here, nth maxima. This is your x coordinate. Okay, here. This is your x coordinate and this is your y coordinate. Y coordinate is already you have written. Next, x coordinate. X coordinate means what? You are using the formula n lambda d dash by small d. X of nth maximum, position of nth maximum. Generally we used to write y of nth maxima in YDSC. Now because here maximas are in the x direction, this side and this side, x of nth maxima. Okay, so x coordinate of nth maxima will be n lambda by small d into d prime. D prime is nothing but d plus a times 1 minus cos of omega t. That's all. That is a x coordinate of nth maxima. Similarly, y coordinate of the nth maxima will be always from here. So y coordinate of nth maxima will be directly, you can write d plus a into 1 minus cos of omega t. That's all. Okay. Of course, in fact, if it is below, then you just put a minus for the total. Okay. Hope this is clear, right? A very good question, just which is involving a little bit of equation of SHM properly, writing that. Okay, and see, most of the time the position whatever we do, no, n lambda capital D by small d. So d accordingly, whatever the d changes, that as it is function you substitute there. That's it, and it will be, problem will be solved. Sometimes the question can be like this. Yeah. So even the questions can be like this. Suppose you have IDSC, this is a screen, Somebody is moving the screen like this with some velocity. That means this value is changing at a rate, some speed it is changing, right? So whatever you get here, no, x n lambda capital D, D means x by small d. This is changing with respect to time, that as is you put it, right? When it is changing with respect to time, right? Okay, so x coordinate of nth maxima and y coordinate of nth maxima. And what is A? A is already this one. A is this one, right? And omega also is omega, spring lock system, omega value is nothing but root of k by m. That you substitute for omega, and A value also you know mg by k, and you will get x of nth maxima and y of nth maxima. Okay, hope it is clear, right? So any problem involving the screen is oscillating in SHM, right? The initial position of the screen, final position of the screen. In that also maximum lot of questions that can be manipulated. Idea is same. Okay. Should be in a position to solve, right? Okay. Or sometimes here one more thing is like the screen is kept like that, source only oscillating. That question is maybe also we have framed one more question on that also, right? Anyway, so we'll take the next question now. So here, as and when we see the figure, we have two glass slabs, right? One is having thickness T1, the other one is having thickness T2, and completely the medium is filled with a water or some, water only. Not only the glass slab, and also water is also there, right? All this together. Okay, let me read the question. A screen is at a distance of capital D is given 80 centimeters. From the diaphragm having two narrow slits S1 and S2, small d 2 mm, yes. S1 is covered by a transparent sheet of thickness, yes. S1, thickness is 2.5 micrometers, and S2, another, you are covering thickness 1.25 micrometers as shown. Both the sheets are made up of same material. Here also nu is same, here also nu is same. Nu of this slab is also same, nu of this slab is also same. So let it be nu here, let it be nu here. Same slab, but thickness are different. Okay. Okay, and water is also filled. This is 1.4. Okay. This is given 1.4, 1.4. Okay, monochromatic light of beam of wavelength lambda is 5000 angstroms. Here lambda 5000 angstrom, that is in air by default. Is incident normally on the diaphragm, assuming intensity of beam to be uniform and slits of equal width. So both will have same intensities. Okay. Calculate the ratio of intensity at C. The intensity at C, they are asking. To the maximum intensity of interference pattern obtained on the screen. See, actually when these slabs were not there, at C only you will get a maximum intensity 4I0, correct or not? Even though water is there, no problem. When no glass slabs are not there, but still if you cover with water totally, because how much path length this one in water and this one in water same, both the waves will reach at the same time. That is why you will get a at C 4I0 provided when no glass slabs. But here glass slabs are there. But if you keep identical glass slabs with identical thickness, okay, then also you will get at point C central maxima only, correct or not? Simple logic. How much time this will take? Same time this will take, right or not? How much speed breaker this is having? This one is also having same amount of speed breaker, right or not? So that is why both will reach here same time. That is clear or not? Okay, right. No mediums are there. Here central maxima. Only water is there. Here central maxima. But water along with two slabs are there. Identical slabs with identical thickness. Then also central maxima. But unequal thickness. So compulsory here you may not get a central max. You will not get a central max. Okay. So what is the resultant intensity at point C? For that you need to find what is the path difference, right? So how do you take the path difference, right? So that is our point. First of all, right. See, this wave is going a how much distance in this medium? Nu T1, right or not? T1 distance it was going, here it is going T2 distance, right? The remaining part is not air, again remaining part is water, right? So how do you get the path difference? Will be the distance what it is traveling in a slab is T1. So in air if you take, will it not travel nu into T1 in air, right? Okay, nu into T1 in air because multiplying with nu. Okay, but the remaining is not air, right? So remaining is water. So only because of this, what will be the path difference you will get, right? So for example, what I am trying to explain you is, if it is like this, only this is there, this is water is there, this is not there, S1, S2, right? So you are talking, this is in air, so the remaining is in water, the same length, the same distance, if you take it in water, how much that will show? Because if it is not there, if it were not there, then that much distance the wave would have been covering same distance in water, right? So how much distance it was covering in water? If the slab was not there, it will cover a distance of T1 only in water, if the slab was not there, right? So that is equivalent to how much distance in air? So nu of water into T1. This is the path length, okay? Suppose if water was not there, then directly you could have taken this one. Since water is also there and you want that completely the path difference, what you want is, this is in air, equivalent in air, for water also equivalent in air, right? So these two you are subtracting. Otherwise, if slab was not there, then if you take it in water, you will get this much, T1 only. It would have traveled T1 in water, right? Okay. Now since slab is there, it will travel T1 in slab. So equivalent how much distance it will travel in air? Nu T1. Okay. Equivalent how much, if slab was not there, it would have traveled in water of T1. That is equivalent how much in air? Nu of water into T1. That is why you will get this path difference. Okay. So that means overall, because of all this, okay, how much it is longer? So this one. Similarly, second slab also. Second slab also will be writing nu of T2 minus nu W of T2. Now the thing is, they are asking exactly at point P. Okay, so this will come like this, come like this at point C. Okay, so geometrically no d sin theta and all because symmetrical, right? Only these are the things. Now, so what you are doing? So are you adding this or are you subtracting? Are you adding this or are you subtracting this one? So definitely, because so if suppose these two are equal, this total and this total are equal, then you will get net is 0 also, because when they are identical, identical means this is also T2, this also T, this also T, then you should get the net path difference should be 0. So you are subtracting actually. This is the net path difference between this wave and this wave. Okay, simple. Suppose if you do not take water, if you do not take water, so forget about this, then what is that you are going to get? Just simply nu T1 minus nu T2, no? Right or not? So like that we will be getting if you are not taking into water. See, generally, in another page I will try to explain. See, only if you take this slab. Okay, so here if you want to get how much path difference you will get, already we were proving this one into thickness, nu minus 1 into T, because this was traveling in air, this was traveling in slab, so nu minus 1 into T. Correct or not? So Why? Because this it will travel t distance in the slab, so nu t minus remaining is in A, so minus t. That like that you are creating the path difference, correct or not? So this way you are getting nu minus 1 into. Suppose in the same thing, if it is filled with another liquid. So for example, listen all of you, nu 2 this one and nu 1 this one. Okay, then what is that you are going to get it? So that time you are going to get it as this is a new one. See, first equivalent in slab it is traveling t. Okay, so how much distance it will equivalent distance in air is not nu 2 into t. Similarly, here this one same t distance it will travel in nu 1. So that equivalent in air nu 1 into t. So now you will get the path difference like this. This is how I am getting actually. So that is why I am getting nu 2 minus nu 1 into t. Provided this was traveling in slab nu 2 and this remaining is air. Correct or not? So similarly for lower one also. Suppose if you take lower one also, some nu 3, nu 3. Okay, then this will, for this also you will write the same expression. So which expression? Nu 3 minus nu 1 into t. Both you have to subtract. Right or not? So this was not there, only between these two you will get this much. This was there and this was not there, only between these two you will get this one. Both of them are there. Yes, this will be the net path difference. Okay, try to think. So this is the main important point. How do you find the path difference at this point when nu 2 is there, nu 3 is there and nu 1 is also there? Then what will be the exactly path difference here? And that too at the symmetry central maxima point. What is the path difference? Otherwise, if you take here another condition, I will show you. Okay, so if you are able to write this condition, no, lot of problems are becoming very easy. Slab, and this is, let's say nu 1, nu 2, nu 3, T1, T2, okay, all different, right? And you want at this point P. Now, how do you find the net path difference at point P? Right? If you can write this step, no, most of the problems have been covered, right? So I'll write it. Okay. So let us write the net path difference at point P, right? First, see this down one is longer means I'll take positive. First of all, this is geometrically longer than this. This is geometrically longer than this by d sine theta, delta x, d sine theta. Then this is optically also. Optically means I'll write nu 3 minus nu 1 into T2. Okay. Nu 3 minus nu 1 into T2. This also I'll put plus. Why? Because down one longer means I am putting plus sign. Okay. This was geometrically, so d sine theta plus. This is optically, so this one, and this one is longer than this. If you don't take this, that time you will be keeping nu 2 minus nu 1 into T1. So this you have to keep minus. This is the net path difference how you should take at a point P. And if you want to get first maxima, equate that to 1 lambda and get the y value, because d sine theta is equal to y by capital D, to get the y value for that. The remaining things same. Clear or not? Yes. So hope something is entering your brain properly. So these are all the typical things, mainly that steps, because lot of problems are involving in this only. How you are taking exactly the path differences and all, right? Okay. Okay, let us get back that problem. What's the question? So this is the net path difference how you are able to write. So let us complete this question now. So this net path difference, they are asking exactly at point 0. So let us complete this question first of all. So nu T1 minus nu W T1, nu T2 minus nu W T2. So mu is same, of course. So what you can write? You take common T1 minus T2. So can I write this as T1 mu minus mu W T2 mu minus mu W into T1 minus T2. This will be the net path difference, right or not? So what is mu? 1 by 4, 1.4. Okay, 1.4 means you can write this as 7 by 5 minus mu of what of 4 by 3 into T1 minus T2. You are taking as T1 is 2.5 micrometers and 1.25 micrometers. 2.5 minus 1.25, so 1.25 micrometers. So 10 power minus 6. So we'll get this answer as 7 by 5 minus 4 by 3. 120, 1 by 15 into 1.25 10 power minus 6. This so many meters. That is a path difference, right? Any other simplification? I think this will be 5 by 4. Okay, 5 by 4, 3, so 1 by 12. So delta x. Okay, delta x you got. Okay. But, and what is the wavelength? 5000, right? So once you get delta x, how do you find the phase difference? 2 pi by lambda, which is 5000 angstroms, 5010 power minus 10 into delta x. So delta x is nothing but 1.25 by 15 into 10 power minus 6. Okay. So first we'll try to calculate this one. This will become 1.25 into 2.5, 0.5 thousand. Okay, much pi. So this is all this together 10 power minus 7. So we'll go here 10 power plus 7. So remaining here 10 will be there, right? And 1.25 into 2.5 twice, and here you will get 30. Okay, so 10 by 30. Okay, so pi by 3 you will get. Calculations. Pi by 3. Phase difference. So when phase difference is pi by 3, amplitude becomes root 3 times. A and A, 2 amplitude, so becomes root 3 times. So intensity will become 3 I naught. Right or not? So, but they are asking the ratio of intensity at this point, which will be 3 I naught, and central maxima means 4 I naught. So ratio will be simply 3:4 is the answer. Okay, the answer will be, that's all. Right? Because you are getting 60 degrees. 60 degrees means what? So resultant intensity will become 3 I naught, and already maximum intensity will be 4 I naught, provided this is I naught and this is I naught. That's all. Okay, right. Okay, next question. The main theme is this one, right? How you are taking the path differences. Okay, so next, two identical monochromatic light sources A and B, intensity is 10 power minus 15 watt per meter square, produce wavelength of light 4000 root 3 angstroms. A glass of thickness 3 mm is placed in the path of the ray as shown in the figure. Okay, here also you are putting a glass slab, same. But the thing is, the refractive index of the glass slab is not a constant, rather it is varying with respect to x. Yes, it can vary. It's made up of some non-homogeneous material. Okay, x is in mm. It's the distance of the plate from the left to right. Calculate the resultant intensity at the focal point of the lens. So here, what is the resultant intensity, right? So first of all, how much path difference that it is going to create, let us check. So you are having this is a glass slab. Okay, so totally how much it will create? So take a small strip of thickness dx, distance is x. Okay, this is having a refractive index of this one. Okay, a distance is dx, right? So for that, dx distance in a medium of refractive index is this one, is equivalent to how much distance in air? Definitely I told you nu times. So nu means 1 plus root x times the dx. This is the equivalent distance of this distance in air. Okay. Here once again, see there is a distance of dx in this medium. Which medium? This medium. That is equivalent to how much distance in air? The nu into that distance. That's what we are doing. This is the equivalent distance. Why? Because why it will be more distance in air? Because obviously when it travels some distance x in a medium, definitely it will travel more distance nu x. In the same time, it will travel nu x distance in air. So that is why you will take like that. Okay. All right. And that is only for this. So similarly, this distance equivalent in air, this distance equivalent in air, this distance equivalent in air, all that. So from 0 to 3 mm, you have to integrate. Then this will be the total equivalent distance in air you will get. So if you do that, I think x plus, so root x is x power 1 by 2, x power 3 by 2, by 3 by 2, so 2 by 3, right? Substitute the limits. So 3 plus, how much you are getting? 2 into 3 power 3 by 2, so 3 root 3. So that means 3 plus 2 root 3. Okay. So that is this one. And same thing in air. Air it will be 3 mm only. Right or not? So that's why now we are talking about the path difference. What it will be creating is 3 plus 2 root 3. 3 plus 2 root 3 was this equivalent distance in air minus that same distance it will travel in air is 3 only. So path difference will be 2 root 3 mm. This will become the path difference actually. Now path difference, you will have to calculate the phase difference, and after that you have to calculate the resultant intensity. Very simple. So path difference is 2 root 3 mm. So let us calculate the phase difference. Phase difference is equal to 2 pi by lambda. Lambda is already given 4000 root 3 angstroms. Okay, 10 power minus 10 meters into delta x. Delta x is 2 root 3 mm 10 power minus 3. So phase difference, how much you will be getting? Okay, root 3 cancels. Come on, calculations. 2 F4, so 10 power minus 7 will go up to 10 power plus 7. So 7 minus 10 power 4. So 10 power 4 into pi. Okay, phase difference. So much phase difference is what you are going to get. So 10 power 4 into pi means definitely it is a nicely an even multiple of 2 pi only, right? So once it is a multiple of 2 pi, definitely you are going to get a maxima only. So maxima means the answer is you will be getting 4 I naught, where I naught is individual. Individually what intensity? Individually 10 power minus 15. So 4 times of that. Okay. So we'll get answer is 4 times of 4 into 10 power minus 15 watt per. So that means you are getting a maxima, right? Here you will be getting a maxima only because the phase difference is 10 to the power 4 times of pi. Okay, right. Next, we'll take the next question. The next question, two parallel beams of light P and Q. Separation between them is D, each containing radiations of wavelength 4000 and 5000. This is having a 4000 angstroms. This is having 5000 angstroms. Two parallel beams. Okay, separate parallel beams. This is separate and this is separate, right? So which are mutually coherent in each wavelengths respectively. So this is also coherent, this is also coherent in each wavelength respectively. Are incident normally on a prism as shown in the figure. Refractive index of the prism as a function of wavelength. The refractive index is for two wavelengths. This refractive index is not same. It is behaving differently for the different wavelengths. So we know already refractive index depends on the wavelength. Okay, 1.20 plus b by lambda square, where lambda is in angstroms and b is a positive constant. Value of b is such that condition for total internal reflection at the face AC is just satisfied for one wavelength and it is not satisfied for the other wavelength. You find the value of b. So this is the first bit. So you need to find the value of b, that's the first bit. Okay, second bit, a convergent lens is used to bring these that we'll see later. First, how do you find the value of b? See, two wavelengths are there. They'll pass. This one is going here, this one is going here. Out of these two, one will have a total internal reflection. Like that, the value of b is set. This one will become the critical angle. First of all, for which wavelength nu is more? Nu is more, for lambda is less. So for 4000, nu is more, right or not? And one more thing, both of them are falling at what angle? Theta only, no? Incident angle is theta only, right or not? Right. And critical angle is given by critical angle theta c is equal to sine of the critical angle is equal to 1 by nu. So it means that when refractive index is more, critical angle will be less, right or not? The refractive index is more, critical angle will be less. So that means refractive index is more for this one or this one. Let us say this is nu 1. For this one you take nu 1. For this one it is nu 2. Which is greater, for 4000 or 5000? Means definitely for 4000 refractive index is more. And for 4000 refractive index is more, then it will have less critical angle. Critical angle will be less for that. So when critical angle is less, there is more chance of getting total internal reflection for this one only, because both of them are same theta, right or not? Already clear given that one is getting totally internal reflected. So only chance is this will get total internal reflection, because this theta, whatever you are saying, this is greater than the critical angle. But this theta is not greater than the critical angle, because this critical angle is high. Theta is same, right or not? So it is something like this. Suppose the critical angle is, let us say, 40 degrees. Critical angle for this one is 40 degrees. Then obviously this one it is 50 degrees. And light is incident at 45, right? 45 for both 45 only, no? 45 is greater than 40, because critical angle for nu 1 is 40. But here 45 is less than 50, because this critical angle is 50 degrees, correct or not? So that is why whenever they have given one is only total internal reflected, compulsory 4000 angstroms only total internal reflection happens. So that means this theta is such that exactly equal to critical angle of this. Okay. So critical angle for 4000 means, how much is the critical angle for 4000? So when you take 4000 angstroms, how much is the critical angle for that? So sine of the critical angle is 1 by nu, correct or not? So 1 by refractive index of rarer, that is 1 by denser. So 1 by nu. So nu is this one. So 1.2 plus b by lambda square. This is the sine of the critical angle. And that is exactly equal, this is the critical angle only according to this, just internal reflected. So this is the critical angle. So sine of the critical angle is this 1 by nu. And here already this is the critical angle. So sine theta is already 0.8, means 4 by 5. That's all. So you can solve this. I think 1.2 plus b by lambda square can be written as 5 by 4. Right or not? So that is 1.25. So b by lambda square 1.25 minus 1.2, 0.05. b is equal to 0.05 times lambda square. Right. So that is the value for b. 0.05 into what is lambda square for 4000 angstroms. So it will be, so you are taking the angstroms, right? So how much? 4000 means you will be getting 4000 angstroms. So 4 into 10 power minus 7, right? Because 4000 10 power minus 10. So 4 into 10 power minus 7 whole square 16 into 10 power minus 14. That comes out to be 16 into, this will really happen, 16 into 0.05 is 0.8, 10 power minus 14, which will give us 8 into 10 power 50. And that is in meter square. It's the value of B. Okay. First bit, so they're asking the value of B, correct? Value of B is nothing but 8 into 10 power minus 15 meter square. That is the value of B, right? Next, second bit, a convergent lens is used to bring these transmitted beams into focus. So again, they are asking like transmitted. See, transmitted means you have to take a condition that this is also just slightly less. Earlier you are taking slightly more than the critical angle, so slightly less, then only it will transmit, right or not? So assuming that it is going to transmit, okay, and here also it is going to transmit. So if the intensities of the upper and lower beams immediately after transmission from the phase ACR, 4i and I respectively, find the resultant intensity at the focus. Suppose if it is getting transmitted, that means it is not the critical angle, it is getting transmitted, here also it is getting transmitted. After transmitting, this intensity is becoming 4i, this intensity is becoming I. Why it is getting only I means it may be traveling more distance, so more absorption, so less intensity while coming out. Here it is traveling less distance, less absorption, so getting 4i. So 4i and I, right? So how much they will form? You are bringing it to focus. So whenever you are trying to bring it to focus, actually clearly given that starting only mutually coherent each wavelength separately. Which are mutually coherent in each wavelength separately. So when they are coherent, so here by the time this wave comes here, this wave will come here. By the time this wave will come here, right or not? Coherent. Okay. So this will be coming exactly here because you will take the corresponding waves like this, plane wave. After this one, we will be taking, just imagine that Huygens wavefront, right? So the thing is, it's very simple. By the time this one will reach here, this one will reach here, so it will continue like this, as if they are in the same phase. So when these two are in the same phase, coming together, 4i and I same phase, when they are brought to focus, same phase, they will undergo constructive interference. With 4i and I constructive interference, you will get maximum intensity root I1 plus root I2 whole square, root 4i plus root I whole square, which will be 2 root I plus root I, 3 root I whole square. So that will be, will be the answer. The resultant intensity at the focus, you are going to get exactly the, okay. Hope it is clear. How that coherent principle goes, just recollect the Huygens wavefront theory, okay. So same thing will be coming, right. So two questions here. One is actually based on the total internal reflection, it is the geometrical optics and getting the value of B. Second one is the wave optics, so combination what they have given, right. Done. Next question. Consider an arrangement of slits shown in the figure. There is an arrangement of slits shown in the figure. This is the first slit, this is the second one, this is another one, right? Shown in the figure. It is given that D is equal to under root of lambda capital D by 2 and capital D far greater than small d, where lambda is the wavelength of the light used. Find the minimum distance x of the point P on the screen where maxima is obtained. So first, if you look at this, so the wave is going like this, the wave is going like this. Then here they are asking exactly where you are going to get a maxima, right? First, let us check. See, this is also capital D, this is also capital D, right? It is actually very simple. Suppose how much this will create a path difference. Definitely this is longer compared to this one. This is traveling more distance, right? And this distance is D. Exactly if you take D here, then will it come like this? Exactly in front of this, if you take. So how much distance this is traveling? Same, this will also travel, because it's almost like a rhombus. This one and this one are same, this one are same. So this distance plus this distance is same as this one plus this one. So compulsory here only you are going to get a maxima, which is exactly in front of this. So that means x equal to D will be the answer. Directly you can make it. Correct or not? So no need of any small d also value. Okay. So directly minimum distance, that too there are minimum distance x of the point P on the screen where the maxima is obtained. Right or not? Now let us also calculate what is that you are going to get here first of all. So what is that you are going to get here? So that one will come out like this, then this will come out like this. Right? Exactly at this position, let us say C, how much intensity you will get. Let us check. Okay. This is greater than this by an amount. This is definitely greater than this by an amount. How much? So if you take this value and this value, see, already I told you that method. So this is yours. This they have given a small d. This they have given capital D. So this will be under root of d square plus d square. Right? So this is greater than this by an amount. So d square plus d square minus d. This will be the path difference. Okay. So take capital D common and plus d square by capital D square whole power half. Same first derivation what we have done. So that will be nothing but this half will come here, binomial, dd cancels. So d square by 2 capital. Yes or no? Same thing. Okay. So the path difference between this one and this one is nothing but d square by 2 capital D, where d is this one, right? So substitute that. So d value lambda capital D by 2 by 2d. So that means you will be getting lambda by 4. That means this one and this one, the path difference is actually lambda by 4. Now same thing will apply here also. The same situation, symmetric, correct or not? Here also you will get the same. So this is already longer than this by lambda by 4. Here also it will be longer than this by lambda by 4. So totally this will be longer than this one by an amount lambda by 4 plus lambda by 4, which is lambda by 2. So lambda by 2 means compulsory here you will get a minima. Here you are going to get a minimum. Okay. And if you move a distance called as d, then the first maxima is what you are going to get. So here when the waves are arriving this one and this one, you will get a path difference as lambda by 2. But when they arrive here, this one and this one, path difference is becoming 0. That's why you will get a maxima. In fact, here you will get a central maxima. And they are also asking, find the minimum distance x of the point P on the screen where maximum is obtained, x equal to d. Okay, hope it is clear. Right. Go to the next one. Just go through this question. Okay, come on. So consider an arrangement of 3 slits. There are actually 3 slits are there, and a screen as shown in the figure. The wavelength of the light used is lambda. It is given that capital D far greater than small d. It is observed that there are 2 types of maxima formed on the screen, called as principal maxima and also secondary maxima. Okay, something like same model of the concept we will be seeing in the Fraunhofer diffraction also. Which is nothing but central maxima, principal maxima. After that, maximas will have less intensity compared to the central maxima, right? So that the intensity of the principal maxima is 9 I naught, okay, and the intensity of the secondary maxima is I naught. This we have to show, and also find the width of the principal maxima beta 1, and also width of the secondary maxima beta 2. These two also let us try to make it. Okay, please look at the slits. There are 3 slits. Actually, I naught, right or not? So it is a typical question. Something like 3 waves are there with a path difference. So better we go with the amplitudes, right? Suppose if 3 are there, amplitudes A. Okay, so all 3 are having same amplitude. A. If all are in the same phase, nicely you will get the resultant is 3A. And when you get the resultant as 3A, automatically the intensity becomes 9 times. Agree or not? So for A it is I naught, automatically 3A means you will get 9 I naught. So in order to get 3A, all should be in the same direction. Right or not? But all cannot be in the same direction because here definitely they are getting a path difference and similarly phase difference. This is coming like this coming here, this coming here. But what is the path difference between this one and this one? 0, right? But this one and this one cannot be 0 at all. Correct or not? Do you think that all 3 are coming at the same time? No chance. But what about this one, S1, S2, S3? If you take, but definitely S1 and S3 they are coming at the same time, right? Now what can the chance be so that this also will be in along with this one? All 3 will make a central maximum. Okay. So what you may get? See, if I take the path difference between these two, if it is 1 lambda, these two because it cannot be 0 anyway. This one and this one can be 0, but these two cannot be 0. If I take between these two, okay, this is reaching early, this is reaching late. So this is quicker than this. If you take that path difference as lambda, right, then definitely these two will form a maxima. And if you take between these two lambda, definitely between these two also lambda will be there. Correct or not? So then definitely all these 3 will make a maxima here, central maxima, what they will call, right? So for that, what is the condition? Between these two you should get what? Lambda, right? So how do you take between these two as lambda means what is the path difference between these two? So as I told you, d square by 2 capital D, because this minus this, d square by 2 capital D, that should be exactly equal to, then it will work out. Okay. And yeah, that time you will get definitely here 9 I naught. Let us consider only the principal maximas where you are going to get a 9 I naught. Okay, d square by 2d should be equal to lambda. That is the condition. Next, 9 I naught. And there is another thing where else you will get again width of the principal maxima means again where you will get 9 I naught again. So that time how do you take that conditions? I am rewriting here. Okay, here only I will show color, right? See, if you consider one more point on this. Another point here. I am considering another point here. This one and this one. All these 3 again can form 9 I naught, chance is there. But in that, no 2 will have a phase difference of 0. Of course, here these 2 are having phase difference 0 and this one between these 2 you are having a phase difference of 2 pi, means path difference is lambda. Now here again you may get a 9 I naught. So all that width of the principal maximum means distance between 9 I naught and 9 I naught. This is a 9 I naught, this is also 9 I naught. So these 3 together will form a 9 I naught. Means first these 2 should interfere constructively, and when these 2 are interfering constructively, automatically these 2 also will interfere constructively, because whatever the path difference you will get between S1 and S2, same path difference you will get between S2. So why? Because this is D, this is also D, and D is very much less very much less compared to capital D, right or not? See, something like this. At this point, whatever the path difference you will get between these two also you will get the same path difference. And between these two, if you take lambda as a path difference, between these two also you will get a lambda. Correct or not? So once again, between these two, if I take lambda, between these two also I'll get lambda. Means between this one and this one, I'll get 2 lambda. Okay, agree or not? First, this one will reach. Okay, this is reaching faster than this, and this is reaching faster than this, right or not? So completely, this will lag. So this will lead then by this by an amount 2 pi if you take, and definitely this will lead by this by an amount 2 pi only. So compulsory that time you will get 990. For that, how do you write the condition? So you can write this condition because this is d. So this is theta. Take. So simply you write d sin theta. Okay. Between these two, the path difference is d sin theta. Okay. So that is equal to compulsory lambda if you have to get. Right. So d into sin theta approximate tan theta is equal to y by capital D lambda. So y is equal to lambda capital D means small. That's the value of y. Right. Or else you can even write between these two, what is the distance between these two? 2d. So what is the path difference between these two? That also you can put it 2d sin theta, and the path difference between this one and this one has to become equal to 2 lambda. Then only between these two lambda and between these two lambda. So total between this and this, I'll take directly between S1 and S3. So path difference between S1 and S3 should be 2 lambda. Path difference, how do you calculate? Distance between 2d sin theta is equal to 2 lambda. So 2 to cancel. So d into sin theta is y by capital D is equal to lambda. So what is y value? Lambda capital D by small d. Same. Either you do like this or like this. Means the same. Right or not? So this is a y value. It's also equal to the width of the principal maxima, where you will get 9I0 and another place also 9I0. Right or not? So just that simple technique what we are following, right? You see, in Fraunhofer diffraction also, if you remember Fraunhofer diffraction, right? We used to divide the slit into two parts, right? So if these two here and here, this will form these two here first one and here first one. If they form minima, all these will form minimas with all these. So totally you will get a minima, right or not? So that time I have used that a by 2 into sin theta is equal to minima condition, which is lambda by 2, assuming slit is dividing into two equal half. Correct or not? Same method will take it here also, right? Okay. So width of the principal maximum will be lambda capital D by small d, right? 9I0, like that you will be getting the points. Okay, next point if you want, somewhere here, then between S1 and S2 you should get 2 lambda, automatically S2 and S3 you will get 4 lambda, correct or not? So that is the next point. Like that principal maximas will be coming that side. So distance between any two principal maximas is called as fringe width of that. That is all regarding for 9I0 we have talked so far. Now let us talk for the secondary maxima, which is the intensity is I0 only. Okay, so for that also we'll talk. So you have to get I0, right? So let us say this amplitude is A, and A. Intensity is of course I0, and resultant intensity is I0 only you should get. That is another maxima. See, the thing is, just a small point. That means two vectors. See, amplitudes you can take it like a vectors. So two vectors can be like this. Third one can be like this. A. And what is the resultant? A only. No? That means these two compulsory 180 degrees. Right. Now, which two are having a 180 degrees phase difference? Means path difference is lambda by 2. Which two will have a path difference lambda by 2? See, is it that these two is having lambda by 2, or these two will have a lambda by 2? Or these two will have a lambda by 2? That's the idea. Suppose if we take these two lambda by 2, they'll form a minima. Then these two are having lambda by 2. Automatically these two also will have lambda by 2, no? Then complete total you will get 0. That is the problem. Able to get the point. Because whatever the phase difference between first two is there, between second two also you will get the same phase difference. Right or not? So that is why you will get total minima. So that is the problem there. So what I do is making sure that between this and this, I'll try to make a minima. And this and this will get cancelled, this will not get cancelled. That is better. No? For that, what is the condition you have to take? So between these two is what? So distance 2D. Right. So that the intensity of the principal maxima 900 and intensity of the secondary maxima is I naught. Yeah, secondary maxima intensity is I naught, we know. Why? Because these two cancels, resultant A, the chance is there. So that is intensity is I naught. Okay, that's okay. Then coming to the widths. Okay. So for that, if I select one point over here, point Q, where you should get I naught, where you should get I naught as the intensity. So how do you select that? So if you take this one is 1, 2, these three should form I naught. Right or not? So what we'll do? So in between one we should be there. So between these two 90, between these two 90s, automatically between these two 180. So the same thing I'll apply. Between these two 90, between these two 90. So between this one and this one automatically 180. So between this one and this one is what? 2D sin theta is equal to 180 degrees. I should get means lambda by 2 is the. So 2D sin theta is y by capital D, lambda by 2. So what is the value of y? Okay. Lambda capital D by 4 small d. The value of first secondary maxima is this value. Lambda capital D by 4 small d. Okay. Hope you are able to follow that. Right. So I am taking directly, these two should form a minima. So this will be remains like that, which is I naught. These two form middle one. So you don't try to form a minima between these two. Because whatever the path difference you will get between these two, same path difference you will get between these two also. That is the problem. If between these two only, if you get something like 180, between these two again 180, right or not? So problem, you will get, so that time also, if is A, okay. So first is what? This is A. So this one will lag A. This will again lag, again it will come here. So this A cancel, another A will be there. Agree? Okay. So that is all. In that way also you can make it. So in that way if you make it, so you have to check between these two also. What you will take is between these two, it will be d sin theta that time. D sin theta is equal to same lambda by 2. So d into y by capital D, lambda by 2. So y will be lambda capital D by 2 small d. Also you will get a I naught intensity, not denying that. Okay. And here also you will get an intensity, lambda capital D by 4 small d also I naught you will get. So here also you will get I naught. Okay. Maybe here also you may get I naught by using these three. Okay. Here also you will get I naught, here also you will get I naught, here also like that. Different places you will get I naught. Okay. First two you just count. So the thing is very simple. First one you are taking between these two, if it is itself is between these two, if it is lambda by 4, between these two also lambda by 4. First I am taking between first one and third one as lambda by 2. Then this is a condition, lambda 4d. Second time what I was taking is first two only lambda by 2. Okay. Next two also lambda by 2. First and last you will get lambda. Right. So that time you will get 2a this side, a this side, resultant will be a, means resultant I naught. Then also it is correct. So now fringe width is, this is the first secondary maxima, this is the first secondary maxima, this is the next secondary maxima. So what is the fringe width? This maxima distance minus this maxima distance will be fringe width, which will be lambda capital D by 4 small d. For every lambda capital D by 4 small d, you will get a fringes whose intensity is 2 I naught. Sorry, whose intensity is I naught like that, which are called as secondary maximas. There are some points because 3 waves are interfering to get a I naught. At which point they are getting a I naught? That is a question, right? Okay. So this is this question. So very good one. Next, we'll go to the next one. Right. A convex lens of focal length 50 centimeters is cut along the diameter. Okay, this is a convex lens which is cut along the diameter into two identical halves A and B, and in the process layer C of the lens of thickness 1 mm is lost. This is lost, and remaining two parts put together to form a composite lens. Okay, so this in between something is lost and still you are able to join that. Okay, so actually this was supposed to be the principal axis, right or not? So when you join these two, so imagine what happens. So for this part and this part you are joining, so for this part principal axis will be below, right? Okay, now in front of this composite lens, a source of light emitting wavelength lambda is equal to 6000 angstroms is placed at a distance of 25 centimeters as shown in the figure. Behind the lens there is a screen at a distance of 50 centimeters from it. Find the fringe width of the interference pattern obtained on the screen. Okay, so how do you start? See, it's very simple. Two halves are joined, right? So two halves are joined, and here is a source. So focal length is actually 50, but you are placing the source only at 25. So you are going to get a virtual image. And for this, if you select only this part of the lens, now you are going to get two images. If you select this part of the lens, what will be the principal axis for that? Okay, below, right or not? So for this part, principal axis below by half mm, 0.5 mm. This is 0.5 mm, correct or not? And this is the source. This is supposed to be the principal axis, right? For only this part. So bottom part, let me not draw first, so that this one. Only top part I will draw. Actually, this is the principal axis. Okay, this is the top part. Okay, this is the source, right or not? This is the top part, this is the source, but for this top part, principal axis below. This is the principal axis. Now, as if source is placed above the principal axis by 0.5 mm, and if you use the lens formula, so 50 and this 25, and you are going to get 1 by V minus 1 by E is equal to 1 by virtual image at a distance of definitely you will get 50 only. So virtual image because focal length double, so you will get minus 25, sorry, minus 50 centimeters as the position of the image. And since the image distance is 50, object distance is only 25, so image height will be double of the object height. So that is why you will get, so this is a principal axis, this is placed above by 0.5, you will get S1, this is the first image at a height from this 0.5, from this center line whatever you are taking, so 0.5. So that means this source, okay, this is the source, this is a line, so here you will get first image. This is the lens, this is the source, this will be the first image, S1. Height from this 0.5, okay. Same model, you will get another one, S2 also 0.5, 0.5, 0.5. At a distance is 50. That means now S1 and S2 are acting like a two sources whose distance is between these two is 1 mm. So D is 1 mm, and distance between the plane of the slits and the screen is 50 and 50, that is 100 centimeters, means capital D is equal to 100 centimeters over. So YDSC with small d 1 mm and capital D 100 centimeters. Can't you find the fringe width? So yes, why not? Fringe width beta is equal to lambda capital D by small d. So substitute that, you will get the fringe width. Hope it is clear. So it's all this manipulation, cutting in between and joining to get a single source acting like a two different sources. The two virtual images which are formed, which generally these type of problems will be doing in ray optics. So the two types of virtual images, whatever are that going to be formed, they will act like a two coherent sources with D as the 1 mm and capital D, so you'll get the fringe width line. Hope you can do it. Right. So still, so different other questions are there. So almost all the same models. Okay. So but right now we'll stop the questions here. Okay. So do practice, especially I think that some of the typical models, whatever are there, especially variable refractive index, and when glass slabs are placed in a medium is also there, how to find the path differences, right or not. So hope we have covered to the best of the different model of the problems. Okay. So wave optics is one of the very good chapter, especially for the JEE advanced. So always questions are going to be asked. So definitely there were, you were getting that matrix matching also, and more than one correct answer type of questions will be definitely asked in the Young's double slit experiment. So only all the questions will flow on the only one ideas, that is the path differences, phase differences and all. So definitely this will you have to spend a less time, you can spend less time, but if you are getting a questions on that, you can achieve more on that, right. So anyway, so we'll stop it here. Thank you very much, and hope you'll do the good preparation for your JEE advanced exam. Okay, so meet you with the next topic. Thank you.